Hi, I'm Bogdan Amidzic from Creator Studio. In today's lecture, I will show you how we advanced our USD pipeline. This lecture is actually part 2 of lecture that I held on CGA Festival a couple of years ago. Back then, what we showed is how to package USD assets, how to handle variants, how to handle rigging and animation of USD assets, so your caches will be lightweight. Also, we showed whole pipeline from animation to light, and some prototype of our multi-shot workflow and some Karma rendering tips and tricks. Today, I'm going to show you how we benefited from USD, some tips and tricks how to improve your SOP to LOP workflow, how to package effects assets, and how to instance them. What you see here are shots from Serbian documentary film called Drava. In this project, we had to deliver hundreds of shots with relatively small team of people. And in this project, we did a lot of effects like explosions, ground explosions, building destruction. Also, we did a couple of fully CG environments, dozens of vehicles. And for us, this project was really good testing ground for developing our new USD pipeline. So here I will show you typical workflow for creating environments. We have height field and we want to scatter some trees on this environment. And we want to instance these trees in Solaris. So for terrain, we already prepared terrain geometry. It has nice viewport proxy. For trees, we load the asset of the tree, and this asset has some variants, as you can see, and we can choose which variants we want to use in instancer. Okay, so we hook this tree into instancer, and from SOPs we use points, and we have our trees instanced in the scene. So what is the problem? If we want to tweak these trees, we have to go back to SOP level and make some adjustments, and we don't see much of our adjustments in SOPs, especially if we do rotations. So yeah. So to see our results, we have to go back to Solaris, and one way to handle this is to pin Solaris viewport. So we see changes in Solaris. Okay. Yeah. Okay, so one instancer finished. Now, if we want to add another layer of scattering, let's say rocks, so we tweak height field scatter for the rocks and create output null for the rocks. And then in Solaris, we have to create another instancer node and to load these rocks. Now we want to create some cliffs, and also we use height field scatter for this, create a mask where these cliffs will occur. And then inside Solaris, we create another instancer. So if you have many of these assets, you will have many of the instancers inside Solaris. So we actually do a double job here. So we create height field scatters in SOPs, and then we have to create instancers in Solaris. And for these cliffs, what is even more problematic is if we want to affect terrain by these cliffs, we have to re-import them back into SOPs in order to project their geometry to height field. And finally, we have our scene composition. So we have 3 instancers, one for pines, one for small rocks, and one for cliffs. And this gets merged with terrain and rendered out. In the meantime, Matrix demo came out, and really nice thing that they used in this demo was a point cloud which tells where which instance lies, what is the orientation and the scale. So basically 90% of this city are instances. And I was thinking, is there a way to do this in LOPS? So we created some tools in SOPs and LOPS which would help us streamline this process. So first tool is our USD loader, which loads all asset variants aspect primitives. So in SOPs, you get all the variants aspect primitives. You can filter these variants, and they're ready for scattering process. And these primitives have some attributes like which USD asset are they and which variants are they. So if we hook them directly to height field scatter, what we see is good representation inside SOPs, what you will get in render. And you can even manipulate these primitives like scaling of some of these variants. And here you see how it works. So you don't have to jump between LOPS and SOPs. So for the cliffs also, we load it with our node, and we can pick which variants we want to use. So this is not so developed, so I have to do some replacements of strings, but it can be improved, of course. And we have our cliffs, and we tweak them directly in viewport. And a good thing is that we can hook them to height field project and directly work from the same network. So we don't have to bounce back to LOPS. And here we see that all of our instances are collected, so only peg primitives are kept. Okay, so we have a bunch of pegged primitives, and we unpack them just to get pegged USDs with orient and scale attributes. So now inside of Solaris, we have node for loading of these instances. So we just give it a path where we want to put it in scene graph, and then we point it to this like point cloud collection of assets, and we get it on one click. So we don't have to make 3 instances. Everything is done for us under the hood. And what is really cool about this tool is we can also toggle generation of proxies. So we can represent them as points, while in the rendering we see them as fully rendered assets. And also we have option to generate boxes instead of points for proxies. If we inspect USD import node in SOPs, what we will see inside is a LOP network, which just loads USD file. And then in the SOP context, we have LOP import, which just imports this file into SOPs. So we use that in our tool as well, but with one difference. In our tool, there is explore variants node, which basically gives us all the variants. And then is inside SOPs, what we do is we create some attributes like a USD asset and var as variant. So these attributes are used later in the instancing and loading of these assets in Solaris. So the tool that loads these instances in Solaris, what it does, it has a SOP part which just filters the data that's coming from SOPs, and we create 3 primitives in this case for 3 USD assets. So these primitives are just dummy primitives. So yeah, it can be curves, boxes, whatever. And these primitives have information about which assets to load. And then inside of stage, we have these 3 primitives. And we use for loops to reference primitives with some Python scripting. So yeah, so we use this Python script to add to load these USD assets. Then we have explore variants, and then we have for each one of them instances are being created, and it works in for loops. So no matter if you have 1 or hundreds of these, it will work. And this part here is about generation of proxies. So if we use proxies, we delete all the proxies on instances first, and then we create point proxies or box proxies, or whatever user chooses. What you see here are 2 production examples from projects that we recently finished. And in this project, we had millions of instances, and our tool really helped us speed things up. Next thing that we are going to show is how to package your effects into USD asset. So first thing is how to handle volumes. You should always use volume loop to load volumes. And when you save your final USD file, it will be a couple of kilobytes. It will just contain references to your VDB files instead of SOP import, which would save your volumes again alongside with USD file. And when we merge these volumes, we configure them to be visible only in render. And then we create proxy, which is polygonal proxy for viewport. Why we do this is because Solaris is not very good in handling volumes in OpenGL. So what we essentially do is we import these volumes into SOPs and convert them to polygons. So as you can see here, we just convert them into poly mesh. and sample temperature field and transfer it to Polis. So our volumes have both proxy and render parts, and yeah, here we apply some shaders, and as you can see in render they look really like volumetric, nice, while in viewport they are very light. Next thing is how to handle rigid bodies inside Solaris. After some research, we found a tool on the site USD Survival Guide by Luca Scheller, and this tool binds your geometry to skin joints, and it proved out to be the fastest solution. So here we have our asset, look development, and here we have our destruction. And if we layer them together, if we sublayer them, you will see that from left side we get shading information, and from right side we get destruction information. And also we create a really simple proxy for this. And what is very important about Luca's tool is that the number of the primitives that you have in your asset doesn't change. So you don't get as many primitives as there is destruction pieces. And this is very important for Solaris. So if you have millions or 100 millions of primitives, everything will become really, really slow. And the overview of our asset, here we have volumes, here we have rigid bodies, and here we have configure primitive, which tells what is default primitive. And when we save this as a USD file, you can see that it is really lightweight. It's maybe a couple of megabytes because of proxies, but all the data from destruction and volumes are not being duplicated, which is very important. Let's dive a little bit deeper into importing rigid bodies into LOPs. So I will show you different methods to do it. And first one is default method of importing. So this method is creating native instances, and as you can see, it's very slow when loading into viewport, and it creates a bunch of primitives in your scene graph, like 200K, and file size is also big. So next method would be to basically unpack all of the geometry and to save it as geometry cache. And yeah, we see that we add a name attribute, so we get only a single primitive in Solaris. And you will see that this method actually loads pretty fast. It has slight glitch, but playback is around 1 frame per second. The only thing is that files will be huge, like 4 gigabytes for this. So next would be something similar. It's just that we reference packed fragments, and inside SOP import we tell it to unpack, and we will see the write time for this is really similar, but file size is a bit less. It's 4 times less actually, so it's around 1 gigabyte. And performance in viewport is similar. So it's pretty fast. The only thing is that we have too many primitives still inside Solaris. So previous unpacked method had only 1. Okay, so the worst method you can use is create point instances, and in this case it doesn't make any sense. So it's slow to write, file size is big, and you will see like viewport performance it literally takes 3 to 4 minutes to load it into viewport, and playback is the same. So you should not use this unless all of your pack primitives are the same, like same rock, same tree, whatever. But also this method has a lot of primitives in SimGraph. Next one is overlay transforms. This method just exports transformation data on primitives. So you will see down there is XForm data on the primitive. So this is very performant, and the file size is not too big. It takes some time to write it. And next thing is to reference your RBD sim points to node called point transform, similar like copy to points does in SOPs. So this method and overlay transform are pretty similar in terms of performance. And then at some point I started doing some R&D. So I was thinking, is there a way to actually do this in render time? So I have one primitive and I want in render time to see the instruction. I don't need to see it in viewport, and this is the result. And my approach here was to create displacement shader which would do this. So basically this displacement shader references one BGO file which has information about rotations and transformations of these shards. And I have some attributes on geometry, and basically I do transformations inside of displacement shader. And this was in Houdini 19.0, and then we found solution from Luca. And this solution, what it requires is static geometry and RBD points. And I just wrapped his tool into HDA. So this is how it looks when you load it. You just have to put one Python node which would correct normals. But performance of this tool is very good. You get like 1 frame per second, and size of final USD file is around 200 megabytes. So it's very lightweight, and the write time is around 30 seconds. So it's very fast. And the last solution that came out in Houdini 20.0 is RBD procedural. And this is something that we all waited for a time. So it takes similar inputs as Luca's tool. So it takes RBD sim points. Actually, this is fracture geometry. Yeah, and this fracture geometry, it requires to have a proper name attribute. So the full path plus shard name. And inside, on the front end of tool, you just point it to BGO, sim point cache. And you have option to preview it, but you don't want to cache it with that turned on. So there are attributes on the geometry which do things under the hood. So you cache it without preview procedural turned on. And then when you load it, you just put Houdini preview procedural node and you get preview in viewport. And you will see that performance of this tool is pretty good. It's a bit slower than Luca's tool, but it's pretty good. And we have only one primitive inside Solaris. So these two methods, skin deformed joints or RBD procedural, are the best. Next effects asset that I'm going to show you is this kind of like splash asset. And we will see that this asset actually has some variance. So there are 4 variants, and if you look really carefully, you will see there are some differences, not too obvious. If you look at the scene graph, what we see is these 4 branches for each of the 4 variants. And in each one of them, we load USD files for point data. And how we actually exported these USD files is basically how we didn't do it is we didn't SOP import them. Because if you do this, you will actually cache your BGO data again. So this point data will be cached inside of your USD file, and we don't want this. Like, we don't want to duplicate terabytes of data again. So we used USD stitch clips utility or ROP, which basically creates really lightweight USD file which just points to your BGO files. And yeah, this is the result. In Houdini 20, there is a tool called geometry sequence in which you just load your BGO files, and everything is way more simple now. And when you hook this into your graph, no data duplication will occur. So this is very cool. So if we look at our graph, all of these branches go into add variant node, which adds these branches as different variants. And then the only thing that's left is to default. It's to set which one of these variants is default, to add materials, and to write out final USD file. And this USD file is also very, very small on disk. Having all of these variants inside of our effects assets poses a question: why wouldn't we instance our effects assets? And here you see a scene, the airport, that needs to be destroyed. So what we do is we import geometry from USD into SOPs, and then we create really simple particle system which will tell where destruction should occur. And then for geometry, for these assets, we create some attributes like asset name, type, and so on. And we detect which particles had hit these assets. So if they hit these USD assets, particles will become red, and we can split these particles to one side, and all the particles that hit the ground will be split on the other side. And then inside Solaris, what we can do with some not too complex Python script, we can actually trigger sublayering of destruction assets on top of our buildings. So here we just sublayer appropriate effects destructions for planes, trucks, buildings, and so on, based on these particles and their timings. And yeah, these viewport proxies now prove to be really essential. And for ground explosions, we just instance ground explosion asset. And when we time it according to particle data, we get this. And yeah, we can we can render it in Karma. So this is a little bit of speed up. And we see immediate results. And in our viewport, we have some, let's say, decent performance. It can be worked on. So this is sped up 2 times. So it's not the fastest thing, but it works. So the idea was to give animators control to art direct timings of the effects. So that's all for today, and hopefully at some point in this year we'll release part 3. Thanks.